So our next topic is electric potential. Electric potential means it is a physical quantity which determines the flow of charge from one body to another. जब हम लोग यहाँ पर बोल रहे हैं कि charge is flowing means electron is transferred from one place to another. तो यहाँ पर ये जो ट्रांसफर हो रहा है मतलब यहाँ पे कुछ वर्क डन दैट इज नोन एज द that is creating a difference, and that difference is known as electric potential. So it is a physical quantity that determines the degree of electrification of a body. कितने रेट में वो बॉडी इलेक्ट्रीफाई हो रहा है, that is known as the electric potential. So electric potential at a point in the electric field is defined as the work done in moving a unit positive charge from infinity to that point against the electrostatic force irrespective of the path followed. So V equals to W by Q. V is representing here the potential difference, W is the work done, and Q is the charge. So SI unit of electric potential is volt, that is represented by the letter V, or joule per coulomb or Newton meter per coulomb. It is also named after the scientist Alessandro Volta, an Italian physicist. तो अगर हम लोग 1 वोल्ट को डिफाइन करने जाएंगे तो ये क्या है? इट इज इलेक्ट्रिक पोटेंशियल एट अ पॉइंट इज 1 वोल्ट इफ 1 joule of work is done. 1 joule of work is done in moving 1 coulomb of charge from infinity to that point in the electric field. This is the potential difference. Next is the symbols used in circuit diagram. What are the symbols that we are going to use in theoretically in representing different kinds of appliances in the circuit? So electric cell is represented by a line, a long line and a short line, where the long line is representing the positive terminal and the short line is representing the negative terminal. Battery is the combination of cell. So here you can see here positive, negative, like this we can attach one and more cells together to make a battery. Switch when it is open, and this is a dot in between the two brackets is representing the closed circuit. Wire, joint, wire crossing without joining. Electric bulb we can represent by drawing a particular bulb, or we can represent it by this symbol. Resistor or resistance, variable resistance or U start, ammeter, voltmeter. These are the symbols used in drawing a circuit diagram. Next is the Ohm's law. Ohm's law is the electric current flowing through a conductor is directly proportional to the potential difference across the two ends of the conductor when physical conditions such as temperature, mechanical strength, etc. remain the same. This is the Ohm's law. Ohm's law basically is current directly proportional to the potential difference. This current is represented by the letter I and potential difference is represented by the letter V. So I is directly proportional to V. This is the Ohm's law. I proportional to V or V proportional to I. For proportionality constant, we are using R here. R is the proportionality constant. Here you can see a conductor is connected to a cell or battery and there is a electric flow. So Ohm's law experiment is like this. A setup is here, ammeter and voltmeter. Now, when we are doing the experiment, this graph is representing us our observation. Potential difference is directly proportional to current. Means when the potential difference is increasing, current is also increasing. So graph is a linear graph, that is a straight line. So what do you mean by this resistance? The resistance of conductor is the opposition offered by the conductor to the flow of electric current through it. It is the opposition. वहां पर वो उसको अपोज कर रहा है, इलेक्ट्रिक करंट को फ्लो नहीं होने दे रहा है. दिस इज द रेजिस्टेंस. R इक्वल्स टू V बाई I. ओम्स लॉ में हमने देखा था I इक्वल्स टू V R. R. तो यहाँ पर R को अगर हम लोग रिप्रेजेंट करेंगे तो R इक्वल्स टू V बाई I. So resistance in terms of physical features of the conductor is R equals to rho L by A. Resistance किसकी किसके ऊपर डिपेंड करता है? Where rho is proportionality constant called resistivity or specific resistance. L is the length of the conductor and A is the area of cross section of the conductor. So resistance is directly proportional to length and inversely proportional to the cross sectional area of the conductor, and also it depends on the nature of the material. Resistivity depends upon nature of material and not on the geometrical dimensions of the conductor. So we will continue in our next class this chapter. Thank you everyone.